what we have to demonstrate today. My name is Sam Azar. I'm with the Atomic Energy Corporation. It's a company that I started on an idea that I developed about 1.5 years ago, sometime in the early part of 2002. It's an idea that its purpose is to generate electricity using electricity, and the fuel source itself will be water itself. It'll be a very refined source of water, and it'll actually be it's called heavy water. It's not something you can find just out of your tap or your sink. However, it pretty much is simply using water, which consists of hydrogen and oxygen, and using the power of electricity to, at such a very large amount of power, to actually begin to create a condition of nuclear fusion, which creates so much additional heat energy that in return you can then run power generation equipment, via steam generators, and then create more electricity. So, in essence, a feedback machine, to create more energy out of the energy that you're sticking into it. It's not one of these perpetual motion ideas. This has to do in the realm of atomic energy. We all know that in fission, the atomic energy which is used throughout the world today, they use fission. You can have 1 pound of uranium, and that is equivalent to about 100,000 tons of coal. The point is, you can't compare the two. One is atomic energy, the other one is chemical energy, and what goes on, such as gasoline or coal or natural gas. Atomic energy is a different realm. This idea that today I'll talk more about is about fusion. Fusion is the combining of atomic nuclei, not the splitting of atomic nuclei. Fusion, the benefits of fusion are there is no radioactive byproducts out of it. The byproducts also cannot be used in weapons grade material, like you might hear a lot often in the news, that can be used in weapons grade material. You can't do that with fusion. You use an energy source to create an environment for the atoms to fuse together, and that can create a fusion environment. And if it happens, it happens, and if it doesn't happen, that's it. It just doesn't happen, and the atoms that were there, stay what they were. So there is no negative byproduct of radioactivity. And obviously the advantage of fusion itself is the fuel source being water, and number two, there is not much of a pollution cost. And if we can get this thing to work, which I of course would be biased saying this, but I do strongly believe it would work. And if anything, I would strongly say that I don't think there's anybody who could really bring up a good enough argument to say that you can't build a device, a prototype device, to at least try to see if it doesn't work. And in regards to the applications of such a thing, power generation plants, it's something that should be, once you understand what is about to happen, and needs to be tested and tried, that we should try this. We should at least try and investigate, build a large enough prototype device to do this. I have a little demonstration that I'm about to show. It's nothing like the real McCoy, but it's going to show you something about what we need to do. And actually, I think I'm going to do this right away. And in essence, what I'm doing here is creating lightning and water. These are the two requirements that are needed to create fusion in what I'm proposing. Now, the water that I'm using, I just have it inside this standard container. It's not just regular water you can find in your tap water. This water here is ultra pure reagent grade water. There's only a couple companies that make this. It's extremely pure, filtered, take the ions out, take the minerals out, take the organic chemicals out. It's almost pure water. And if you know what water is, it's H2O. It's hydrogen and oxygen bonded together, and it's a very, very stable molecule. There's no reason for it to come apart. However, being this, this is $80 a half gallon here. It's still not the purest, So what needs to be done in the true prototype device is an extremely, very pure source of water, and predominantly, water that is heavy water. Those who understand in physics and people who are watching this video and seeing that what we're about to propose, you should be concurring with some physicists, the basic requirements that need to be done. So it probably would be pure water and a good concentration of heavy water involved. Now what I have here is a transformer. This is a 15,000 volt transformer. And I'm simply, I'm going to show you what a plasma arc first is. When I say this is essentially lightning and water, I need to show you the power of lightning. I'll just use one hand here. Let me turn this on because this is a lot of voltage, so I'm protecting myself. So right now I have A transformer. Transformers can be built on any scale. When you look out in the countryside, there's transformers out there on the largest towers you see that are over 500,000 volts. So the technology is there to do this sort of thing. Now this is a plasma arc. I don't know if you guys can zoom in on this here. That there is to ground, so that should be less. Let me show you a little bit bigger. That there is electricity ionizing through the air. No different than what a cloud does. And I'm trying, and this is, you see how the electricity can jump through the air? Because this is 15,000 volts, has the ability to do this. We need to do the same thing inside here. If you gentlemen could like zoom in on that, wait, I want to move one over to the center now. I want to move this over a little bit more so you can see what's going on. Then let me take this. Okay, there's the plasma arc again. If possible, can you zoom in closely where the purple light is? What is you're seeing there? That there is a very slight ionization of the water actually going on right now. Very slight. We don't have, you know, I mean, there's no reason why the water. Think about this. If water in itself is very pure, there's no ions or minerals. Water itself is just as insulative as rubber itself. You know, if you really think about it, think about that. Water is H2O. It's a bonded molecule. Has no reason to come apart like a metal atoms like copper or aluminum or anything like that. All right, let me take that off and, you know, let's kind of like point up here what I'm talking about. So, let me re-emphasize this. Most people think that, you know, you stand in a puddle of water, this is the time you could get shocked. It's true, because water is filled with all kinds of impurities, ions and minerals and everything else that really does the conducting. You know, it's conductors. Metals are what conduct electricity. They have free electrons that move around the atoms. Pure water is not a conductor. It's a very stable molecule. You know, it has no reason to conduct electricity. But that's not the point. The point here, why water is being used, is this. This would be somewhat. I just quickly drew this on the board here, but this is somewhat of you could say the prototype device that needs to be built. All this is here, this box is representing a vessel, a tank of water. The water will be filled inside here, okay? A large transformer on the outside of several 100,000 volts. I'm predicting that it probably might even be close to 1,000,000 volts. It's going to be a lot of energy. And that energy is going to come into cylinders. These are movable cylinders. You know, I have with the arrow here, but these are like electrodes. Like I showed you a wire, but let's say these are electrodes, you know, maybe 1 foot in diameter, large cylinders that move through the side of the wall of this whole vessel. And this could look like the front of it with multiple electrode tips where, you know, the electrode tips, the electricity could come out. And the reason why it's movable, so you have this electrode and they come in close and it strikes the arc. Like I showed you there, the closer you come to the point, it strikes the arc. Now you have the plasma. Now the plasma is happening where? It's happening in the water. That's your conductor. You know, your H2O, atom of hydrogen and oxygen. They're in here, they become the conductor of that plasma. Now you see in a plasma, it can happen anywhere. Any atom in the periodic table can become a plasma. Let me stop right now and just I'm sure whoever's watching this, maybe you're concurring with some physicists, but just for a little background knowledge, there's 4 states of matter. Any atom, any molecule or any atom, if you cool it far enough, it'll become a solid. You heat it up a little, it'll become a liquid. It starts moving around a little bit. You heat it up even further, it becomes a gas and separates. You give more energy into it, it becomes, you begin to strip the electrons off of the proton itself. That's an ionization state, that is the plasma state, that is a high energy state. That is a state where a lot of light comes off. You know, when lightning blasts through the sky, that ionization, whenever you have an ionization where electrons are separated from the protons themselves, a lot of radiation comes off. Radiation in the form of heat, of light, or, you know, the electrons themselves. The TV that you watch at home, that is actually a beam of electrons that have been ionized, you know, in the back. There's many examples of a plasma. So, but the point being in here is that the plasma being generated is generated inside a pure source of water, a very pure source of water. And that plasma source needs to be so strong. Now this thing needs to be being pulled back. And as it's being pulled back, the energy is being increased because the further the distance, the greater the voltage you need to apply to this thing to keep the plasma state going. Now why multiple? I call these plasma channels. You know, multiple channels created by the architecture of the electrode face itself. You know, an architecture that, you know, that can be worked out there in the development stage. But multiple channels, why? Because a plasma arc is very hot. I mean, So I wanted to just prove this point real quick. Let me just show you, just for, again, demonstrative purposes again. I mean, if I had the plasma arc, and just to show you gentlemen, very quick, you should just understand that a plasma arc is a very hot, source of energy. It's I think you gentlemen see a plasma arc is energy. It's heat. Did you guys get that? Okay, let me do this again. A plasma is a very intense source of energy, of heat. Did you catch this? You guys, it's not just light. A plasma beam is a very high source of all kinds of radiation. I mean, it could be a misleading word. Most people think that radiation is, the type that causes cancerous effects. Radiation truly means anything in the electromagnetic spectrum, such as light or heat. It's considered electromagnetic radiation. But the point I'm trying to say is that a plasma beam creates an intense amount of heat. So this design, we're using plasma channels, separated channels, so the electrons face themselves have the ability to stay cool themselves. But this is the point. When this thing becomes separated and the plasma channels that we begin to generate, now you have multiple channels. Now things begin to happen when you have a very large electrostatic field. One thing's going to happen. With a sufficient enough high voltage, which is what we need to do, one requirement is every electron on the atoms themselves need to be stripped off. Total ionization. Okay? So when one is positive and one is negative, all the electrons that are within this plasma region go one way and all the protons go one way. That is obviously one requirement. But the second requirement is, under a very strong electromagnetic field, the polarity, that this is what we require. The hydrogens that are in here, which are considered positive because they're electrons off, when you balance an atom with its electron, it becomes neutral. But when you strip it, you ionize it, you take off the electron, now you have a free proton, you call it, a hydrogen, has a plus charge. And it's going to want to accelerate by Coulomb's law. It's going to want to accelerate that way. Almost like a magnet. A stronger magnet you have, and you have a magnetic component there, it will be attracted to it. Same thing in electricity. I mean, you might have seen some examples of static electricity. There's a large voltage potential there. An ionized or charged particle will be attracted to that. So the point being, so the second requirement needed is such a large enough electrical field generated here that these begin to move very strong under this electrostatic potential. Now this is what's created. When a charge moves, a magnetic field is created. That's why you can have electricity go through a wire, and you can have a meter, this is a piece of chalk, but you can have an inductive meter and come close to the wire and you can pick up the field. Because whenever electricity moves, which is charges in motion, a magnetic field is created. And this is the key principle here. This is one of the fundamental, how would you say, methods of fusion that need to take place because of this. One of the large electrostatic potential, when you have protons moving in one direction, the magnetic fields all couple, they align, they begin to pinch themselves, they begin to attract themselves. Electrons now that will go the other way, they have an opposite electric field. This is proven, known fact to any physicist who is schooled in the art of magnetism. These two states will occur. Electrons will go one way, protons will go the other way. Not only hydrogen, but oxygen left in here, stripped of all of its electrons, will also go the same way hydrogen's going. So, but this is the interesting thing. The electrons that go this way and the protons that go this way, they will always be attracted towards each other because of the magnetic field under extremely large electrostatic potential. Now, so what's going to happen here, I'm trying to draw a representation of these plasma channels, extending from one electrode face to the other. And because the field starts to grow bigger and bigger, they're going to, like, towards the center, they kind of attract each other towards the center. And that's probably not going to be enough. We need them to attract in the center. Why? A plasma beam, the one I showed you, and even if I made it so large, is going to be extremely hot, would be very hot, maybe even close to the surface of the sun. But to attain fusion, the combining of hydrogen themselves to create fusion, this is the realm of atomic energy now. This is something that most people do not realize, or see in everyday life. You see gasoline combustibles, you see coal, and you see gas. But to see atomic energy, it's a different realm, as we do in fission plants. But in fusion, it takes an extremely large amount of energy to create a condition in here, to create a fusion in this zone, this fusion zone in this center, to create it so hot enough that to make this even possible to happen. So, several requirements. You need to spread these electrodes apart to create a plasma beam in here that when fusion does occur, it's far enough away that it won't melt anything around it, because the temperature where fusion needs to occur is so hot it'll melt any material. So, it needs to happen in this area. And these are the two requirements that are going to make it happen. The large electrostatic field is again going to accelerate the protons in one direction, and they're going to have a magnetic field, and they're going to want to come closer to each other in the center. But we're going to need to stick a large superconducting solenoid. Now this thing here that looks like it's kind of cut, it's a graphical representation of, there would be a large superconducting magnet that needs to be placed in the center of this region. And with that large magnetic field it helps create an additional push on the protons themselves that are flowing through here. And this plasma, they help push them together. So what is essentially going on, what we're trying to create is an environment within water, which is the fuel source, with electricity, a very, very large amount of electricity, to create an environment that the protons of the water, and even the oxygen of the water, is going to move in such a way that they're going to be squeezed in such a way that they will, to create such a favorable environment here to create fusion. So what's this all about? You know, we're trying to make electricity, and here we are using electricity. We use electricity, a lot of energy, to create a plasma environment of a lot of heat. Let's say we put in 1 megawatt of electricity into this. And first of all, 1 megawatt is going to create a plasma, is going to heat this water. Let's say it raises it 20 degrees for a given volume, you know, whatever. But a fusion does occur in this center region. The amount of heat that comes out of an atomic reaction, you know, because of the density being used and a fusion is possible, what comes out is maybe 100 times greater in the amount of heat that comes out. You know, so without fusion, 1 megawatt of power in, you're obviously going to get 1 megawatt out. However, because of trying to convert the heat from water or whatever your mediator might be into steam and then a power plant, you know, you lose about 40% efficiency. So you're losing something. But if you get fusion to happen in the center, and fusion is by far 100 to, depending on the efficiency you can get, it could be from 100 to 1,000 times greater in output of heat, of energy, meaning you put 1 megawatt in, you could get 1,000 megawatts out. I mean, I'm throwing numbers out, but you know, only through testing and prototyping you can find out how efficient you can make you know, like you say, this zone of fusion, how efficient you can make it. You know, maybe what I'm trying to say is, you know, a good design, a good prototype, you know, and testing, you know, we can see how good it is, you know, to make this sort of setup and to see how effective it is to make fusion in this center. Okay, I think that pretty much in a nutshell is what I'm trying to propose. What we at the company, and the company being myself who started it, I have some friends and family and some colleagues, you know, in the area, approximately about half a dozen who believe in this strongly, you know, would like to get this going. This is a large endeavor, you know, I mean, you know, you gentlemen should understand that, ladies and gentlemen, that this is trying to build an electrical power plant. And it's a nuclear fusion power plant. You know, I'm one guy, you know, there's a couple of us, you know, I got rabbit ears for pockets I can pull out here. You know, I've been spending a lot of money on research and other prototype devices to come to this level, to even approach what is as simple as I showed you there. It took many years to get to this point. To tell you a little bit about myself, I would say that you know, there's many kinds of people in this world. You have businessmen, you have sports players, you got all kinds of people. You know, to say a major facet of who I am, I'm a scientist by heart. I love science ever since I was small, and I have been pursuing it very vigorously most of my life. And I would say that the past 5 years on my own, very hard, you know, in various applications. And this idea, you know, as big as it was, I still, you know, when I came across it, you know, in the beginning of 2002, you know, I researched it pretty hard. You know, I was looking at what are they trying today. Today, they use a tokamak device in nuclear fusion, developed in 1952, and, well, they still haven't got the efficiency down, because obviously they don't do fusion today. I mean, it's a tough thing to do, but the way they got it, You know, I don't want to say anything about it. All I can say is for 50 years, they still don't have it yet. Here's an idea, you know, that I realize it's large. I want to propose it. I'm sending this videotape out to potential partners who've got the muscle, who've got the clout, who've got the energy, that believe that maybe this could be done, and maybe would like to try it, like to team up and see if we can join forces. My end would be technical, would be built, you know, and let's see what it can do. Your end, the people that I'm looking for, is you know, without beating around the bush, is on the money end, is on the monetary end, you know, and of course your technical experience, your life experience, you know, who you are. But you know, let's face it, you know, talk is talk, and money is money, and you know, to get this thing done, we need money. And you know, along with the paper that I'll send along with this video, it'll describe exactly what's needed, you know, the various phases and steps that we need to do to accomplish this. And if you're interested, please don't hesitate to call the house, call my place, write to the, you know, go on the website, and you know, maybe we can get together, maybe we can try something. I want to thank you for coming here. Thank you for whoever's listening and took the time out to listen to this idea, and we'll see what might happen. Thank you very much. Take care. We're recording here. I'm going to start another tape and introduce